How you doing today?
Just fine.
Okay, and you are?
Mark Bird.
And you do what?
Design and build the world's most powerful magnets.
Wow. For who?
National High Magnetic Field Laboratory, Tallahassee, Florida.
There's a lot with that technology that's being, that you can play with. There are a lot of avenues you go to. What primarily do you use the magnets for? What do you design them for?
They're mainly for condensed matter physics experiments. So people are studying high temperature superconductors. A lot of the work is with high temperature superconductors. And in general, people are putting exotic materials under high magnetic fields, and the magnetic field changes the shape of the electron cloud of the molecules and makes different things happen. They're materials that, room temperature insulators. If you cool them down cold enough, they become superconductors. If you apply a magnetic field, they become an insulator again. And people are trying to understand why all that happens.
What does this have to do with CERN at all, or does it have anything to do with CERN?
Yeah, CERN has some reasonably high field magnets. I actually know the project leader for building the Large Hadron Collider that was started up a few years ago. And I know quite a few people who worked on that project.
There's a lot of conspiracy theories on this, of course. They're going to open up a portal, so is there anything to this at all? No? No.
There was a person who got a lot of publicity just before they turned it on, claiming they were going to destroy the world. And
that came up. Yeah, well, as I say, you hear these. That's why I like doing these interviews, because when I run across somebody who's got direct knowledge of a field that's like you do, I'm going to listen to you because you're there. But how about with the use, and also there's usage in the area of energy, using magnets to produce free energy, or Tesla technology type situation. Do you evolved, or do you know anything about that?
Well, magnets are used in energy, or people are trying to use magnets in energy production. Standard nuclear reactor is a fission plant.
Right.
It splits uranium or plutonium into smaller elements, releases energy. A fusion plant takes hydrogen or other light elements and fuses them together, and you can release energy from that. And that's the way the sun produces energy. And there have been several fusion reactors built on Earth. Fusion reactors. But none of them produce more energy than they consume to generate that. And that's because they were too small. The world is now building ITER, the International Thermonuclear Experimental Reactor. It's actually being installed in southern France, but it's being built around the world. The parts are being shipped there. It's like a $15 billion project. The U.S. has a piece. Europe has a piece. Japan, India, China, Korea, Russia it's called now. It's a worldwide project, and I think they're claiming they'll be done in 2021 or so. And they'll use a magnetic field to confine the hydrogen atoms and compress them together enough that they start to fuse and release energy. And I believe ITER is expected, I know when it started it was expected to release more energy than it consumes, but maybe they've changed the goals since then. I'm not sure.
Wow. You see a lot of things on the internet and YouTube and all about people coming up with free energy machines using magnets and all. Any validity to any of those machines that they're coming up with? I mean, do you think it's a hoax, or do you think there's actually some garage store inventors out here that are coming up with things that are being suppressed?
Well, the only legitimate way I know of getting energy from magnets is with magnetic energy fusion. There are people, people send us all sorts of stuff all the time.
Sure.
They think NASA has a conspiracy and they want us to prove it.
Don't they?
Things like this. So people build, have concepts of devices with a lot of magnets in them, and they think that, if you spin this thing, it'll just spin eternally and you can use it to make power and run things, and they don't. And it's real simple why they don't. Typically these people are taking a sort of, they're viewing one side of the device and not looking at the other side, which is consuming the energy the other side is. Typically, what happens when you have two, if you take two magnets and you put them so they've got north poles towards each other, they repel. But the problem is, to bring them that way together, you have to put energy in, and when they run apart, you get the same energy out that you put in. Yeah. And so people do things like they make
basic
a
physics,
wheel. They'll make a wheel with magnets on it and a rim with magnets. One is fixed, and you spin it. Well, it's always going to repel from it. Well, it does, but it's also being repelled from the one in front as well, and things. So No, I've never seen anything that I think has any chance of it, but maybe there's something I haven't seen.
Indeed. Have you ever watched the documentary Thrive?
No.
It's Procter & Gamble, you know about them.
Sure.
Foster Gamble was heir to the fortune,
Okay.
groomed to be a top 0.00001%er. And he had an epiphany, and he says, I can't do what they're asking me to do. So he breaks from the agenda, and he makes this documentary called Thrive.
Okay.
Please watch it. It's a tremendous documentary. But one of the first things he does in this documentary is show government suppression of secrets for over 100 years. The first one he brings up is free energy suppression. Things like the Tesla technology. They mention other scientists that, have been bought off. They buy their patents, and then put them on the shelf. Guys have been intimidated, even murdered, who've come up with these inventions. So, I'd highly recommend you look at this because, you're in the field. This is what you do.
Yep.
And it'd be, I'd like to be able to, even after you look at it, I'd love to get your spin on it. I'd like to give you my email address. And after you look at it, tell me what you think of that.
All right.
Because you said you're a wealth of knowledge. You've got you're right in the middle of it. You're the scientist that's doing this stuff. So that's really cool. All right, thanks for your information. I really appreciate it.
You asked also what the magnets are used for, and I told you what a lot of it's used for. There are other applications as well. A lot of applications are in medicine, actually. So there's a number of different ways of understanding the shape of a complex molecule. So a simple molecule like water is H2O. Right. So there's two hydrogens and an oxygen. So there's three atoms there. And they're not in a straight line. The oxygen sits here and the hydrogens sit up there as like Mickey Mouse ears. And there's a particular angle there, I don't recall exactly what it is, but that's been known for decades. And I believe that was done with X-ray scattering. And so simple molecules like water, the structure's been known for a long time. Right. But more complex molecules like the proteins in your cell membranes are much bigger, much more complex. And it's only in the past few years people have been starting to understand their shape and how they interact with each other, how viruses interact with them, how drugs interact with the cell membrane, and how the cells interact with each other, and all this sort of thing. And there's really three ways of doing it that I know of, and there are perhaps a few others. You can do it with high magnetic fields, a process we call nuclear magnetic resonance. You can also do it with X-ray scattering, as I mentioned for water, or neutron scattering. But if you add high fields to either X-ray or neutron scattering, you can learn even more than with either by themselves. And so that's, there's just been a revolution, and a revolution going on now in understanding biology, by understanding how these complex molecules work together that hasn't been known in the past. And that's, so the drug companies buy a lot of these NMR magnets for developing better drugs. Another thing is MRI, which is basically the same process, but looking at a different scale. Instead of looking at the shape of individual molecules, you're looking at a bigger scale, looking at the shape of the organs and things like that. And so an MRI machine, most hospitals have magnetic resonance imaging machines. The standard ones are 1.5 Tesla, the high field ones are 3 Tesla. There's like 30 or 40,000 of those in the world. Most hospitals have one now. Higher fields than that, though, there are very few around. There are some 7 Teslas, about 30 or 40 of them at 7 Tesla and higher. And we're looking at the possibility of building much higher field magnets for MRI. We have a 21T magnet we can do MRI, but it's only about 8 inches in diameter, 4 inches in diameter, so you can do mouse brain MRI. We have the best images of mouse brains in the world. And that's yielded a lot of information about how the brain works, at least in mice. But if we can build a magnet big enough to do human head MRI, we can get the same resolution in the human head that we already have in mouse brains.
This is a two-sided sword, though. I mean, if they map our brains to the point where they can indeed, pretty much know where every neutron does and what's going on, isn't through the use of biotechnology and every other science that they can throw at us, isn't the potential there for this to just become brain-dead zombies to them? Because I would ask you to look this up. Smart dust.
Right.
Have you ever heard of that? Yeah, it's the use of nanobot technology that we can breathe in. These things land in our neutron, coat our neutrons, so they can actually transmit into our brains and just take over our bodies. This is stuff that DARPA works on, and right? But you sound like you deal mostly in the medical field, the medical portion of this. Is that?
Well, the magnets I build are primarily used for domestic matter purposes, but we do some magnets that have more biological and medical applications.
Man, yeah, you got a specialized field for sure, man. This is great testimony. But I would urge you to please go watch that documentary. I'll write it down for you. I'll give you my card. And look up smart dust.
All right.
You can see it.
I'm